Let's do this.
Did you solve yesterday's?
Yes, but also, like, I so my algorithm that I thought up yesterday apparently did not work. So I had to look at my past algorithm and say, oh, that was why. Actually,
We looked it up.
kind of not even that was why. I still don't understand why my current algorithm doesn't work.
Let's look at that then. We can analyze that.
No, no, we should solve today's
Oh,
first. We can
but
analyze that.
today's is very easy. I tell you, it's very
No, no,
easy.
wait, let me solve it and then we analyze if we have time because you might not.
Fine.
We can analyze when you come back after running because it doesn't. I don't have to record it.
Okay.
Okay, yeah, all right. So welcome back to day 25 LeetCode grind. Solve or go home. 30 minutes solve or go home. All right, let's check this. Power of 3. Okay, yeah, I actually don't even know this question. Given an integer, return true if it's a. Oh, okay, that's what it means. Okay. An integer n is a power of 3 if there exists an integer x such that n equals 3 to x. Okay, yeah, so. Wait, do you just cube root it 3 times and that's it?
No, no, no.
Okay, well, if you can divide it by 3, that means it's a power of 3, right?
No. I
Oh, no, no,
mean,
that's a
if
multiple
you
of 3.
keep dividing it by 3, then yes.
Yeah, if you divide 3 all the way down to 1, then it's a power of 3, right?
Yes.
Yeah. So, do you just do that?
Yeah, you can do that. But watch out for the inputs. The inputs can be like 0 and negative and shit. So you have to make sure those are handled.
Okay, so basically, yeah, so if it's 0 or negative, return false, right?
Right.
And then otherwise do the algorithm.
Yep.
Wait, but wait, is that what?
That's
Wait,
it,
is
man.
that it? Are you serious?
Yeah.
If n is less than or equal to 0, return false. Else, then you divide it by 3 until it gets to 1. So while n greater than 1, n equals n divided by 3, and then so okay, wait. So if I do a while greater than 1, it might keep doing 2 divided by 3 is 1, right? So yeah, because then that's the float math. So, I mean int division, right? But then that's wrong because then the 2 isn't technically.
Right. So you should check is divisible by 3 first, and then do that.
Yeah. Okay. So if if n mod 3 equals 0, then you do this. If it's not mod this, that means it's false. Okay, and then while it is greater than 1 and it's mod 3, you keep dividing until, and at the end if n equals 1, then you're good. Wait, so this else case where you return false is if it's not a multiple of 3, you're gonna return false. And this thing should, I don't think you need to check in here again. You can just return true because this will cover every edge case, right? Basically, at any point in time, if it's not a multiple of 3, it's gonna return false, and it's just gonna keep trying to divide by 3, and then it will check each time if it's a multiple. If it's not a multiple, it's gonna return false. So this should work. Let's try 0. Well, 0 and 1 is definitely covered by the negative 1, so I don't think I need to test that. Just test a multiple. Okay, yeah, that looks fine. Yeah, that was super simple. Alright, we can look at my submission for yesterday then.
Yeah.
It was this one. So basically my algorithm was I had a heap, right? And then it was a max heap. So basically, my algorithm was use bricks first, and then in the future, if you have no more bricks, then you check your ladders. If you have more than one ladder, I peek at the heap. I want the biggest one, the biggest bricks back. So then if the brick is greater than or equal to, the biggest brick in the heap is greater than or equal to the bricks you need, then I pop it out and take off a ladder. Else I just take off a ladder if I can't, like the bricks aren't enough.
Well, okay. So I think you have the right idea. And this was actually a little confusing for me as well. But basically, ladders gives you the size of the heap that you want to keep. Right. So let's say you have like 10 ladders, right? Then you basically.
You only want to store.
You want to store top 10. You know. Best uses of ladder, right? Which max heap it works well for, right? So, so basically, well, actually no, it's actually a min heap, but you're popping the lowest ones when.
Yeah, so that was my old solution. I don't know how I thought of that. I don't remember like why I thought a min heap would work, because then a max heap makes more sense to me. Why does a min heap work?
No. So the min heap works because well, you're popping the min each time, right? So it's okay. Like, basically, it effectively becomes a max heap if you use the Python min heap, right? Because as long as you're always popping the min when it gets too big, then you're maintaining that you have the maximum number of sorry, you have ladder numbers of big or the most optimal uses, right?
Is that true?
So let's say you're considering ladder and you have like 3 ladders, let's say, right?
Yeah.
And then your next building is one bigger than your current building, so you put one into the heap, right?
Mm-hmm.
And then when you move to the next one and it's like 2 bigger than the current, and you put 2 into the heap, right?
Yeah.
And then you put 3, and then the next one is 3 bigger, then you put 3 into the heap. So now your heap is 1, 2, 3, right?
Mm-hmm. Yeah.
And then now, so you know for sure you can make 1, 2, 3 because you have 3 ladders. Like basically this costs you 0 bricks, right?
Mm-hmm.
But now what happens when you move to the next guy and it's 4, right?
Yeah.
So 4 goes onto the heap, but you only have 3 ladders, so you can only store the top 3. So if you put 4 into the ladder, 4 into the heap, then you have 1, 2, 3, and 4, and then you check if 4 is too big, and 4 is size 4 is bigger than your size of ladders, so you have to pop now. And when you pop the smallest guy, because the smallest guy is the least worth it use of the ladder, right?
I see. Oh, so you're more of using the heap as like a store of what you're using the ladders for.
Yeah, exactly.
I see.
You store the ladder number of biggest steps that you've used so far, and so you pop out the 1, and you're like, basically.
So if you pop it out, that means you have to pay for it with bricks.
Yeah, you have to pay for it, and if you cannot pay for it, that means you literally could not go past this point. So basically, you have to return your index at this point.
So basically, right? when you're appending to the heap, you're not using bricks yet. You're just calculating how much bricks you need so far, basically.
Exactly.
Okay.
And then you'll never run into the situation where you overspend, because otherwise, like your bricks would be below 0, right?
Okay.
And so and then also you don't run into a situation where, like, let's say you encounter a bigger step later on, but then you maybe use all your bricks, right? Then you can't get to there. So you're just maintaining your most worth it ladder use at each step, and then also maintaining that, like, if you have at least as many bricks as you have the cost of your
I
popping,
see. Okay, yeah.
and then you can keep going.
Yeah, that makes
right?
sense now, because you're only popping the least valuable stuff, basically. So,
Exactly.
And the least valuable stuff is what you use bricks to pay for. Otherwise,
right.
Yeah, you want the ladders to pay for the most expensive stuff.
Right. So now if you code this method, it's like becomes like 5 lines. So.
Yeah, I mean, right. I looked at my old code, which is still super long. I think it was.
I mean, you could try to recode it, right? It's like way shorter, and you don't have to do like crazy logic.
I mean, yeah, I can try it here.
right? So you still
You
keep the
still
heap,
want to heap, yeah, okay. And then
right?
basically you
And you want the current index, right? So
yeah,
res is 0, right?
yeah.
So that part's the same.
And then I still want the prev height, which I use for my crap. Was I think it was heights 0. Okay, so for height in heights 10. All right, so I just calculate the difference between the two heights and I store it into my heap. And then
Yes.
once
Yep.
the height, the length of the heap exceeds or is equivalent, or is it exceed? No, if it's equivalent to my ladder count, then I can't put into it anymore. Right? Is that the algorithm there?
Uh, Sorry, say this again.
Once the count of my heap is equivalent to my number of ladders, I cannot put any more into the heap.
Well, you should always push into the queue, right? And then if you have ladders, sorry, if it's greater than the number of ladders you have, then you have to pop it. So
Oh, so you put it in first and then you check the length.
yeah, yeah, exactly.
And
So
then
if you have no ladders, then you couldn't put it there. You have to process it.
okay, yeah, so you put it in, then you check the length. If it's equivalent to ladders, then you're good. If it's greater than ladders, you have to pop it and pay bricks.
Yes, yes.
Okay, and that way you're never really using your ladders. It's just the ladders
The
is
ladders
the
tell
length of
you
your heap.
exactly,
Okay,
exactly.
I see. Okay, so in that case, yeah. So basically, what we're looking at is we calculate the difference between the heights. So it's heights. No, it's just height minus prev height, and then diff equals. So now we have the difference between this, and then we put into heap dot. No, it's heap q dot heap push, and then it's I believe it's diff and
Heap
then
and diff.
heap. Wait, is it heap first?
No, heap first.
Okay. Okay, so this would store this, and then I check, and at this point I check if heap len heap.
Oh, hang on. You don't push it if it's not if it's like 0, right?
Oh,
Or
right. If diff, yeah, if diff if diff is greater than 0, then you push it.
exactly.
Yeah, because then otherwise it's free. You don't have to put it in. Okay. If it's greater than 0, push it in, and then I check if len heap is greater than ladders, or greater than, no, if it's equal, you don't have to put, yeah, it has to be greater ladders, and then I have to pop it. I have to pop from the heap, so heap pop heap. So I guess this is min. This is bricks needed. And then I do bricks minus equal. Well, I guess I check to see if I can minus it first. If I can't minus, I have to return, right? So if bricks is greater than bricks needed, greater than or equal, then I subtract, else I exit. And then res plus equals 1, else return res. Yeah, because
Wait. Then you're returning early, I think.
is that
Oh, I see. No, that's fine.
because at that point it means you have nothing left. You can't move anywhere, right? Because in diff, if the diff is less than 0, then yeah. So this else case you do res plus 1. And then you keep going, right? Because in this case only triggers when you're diff, you need to pay for it, right? So you can only pay for it with a heap length or bricks, right? So if you have no more bricks, if you can't pay with bricks, then you have to return, right? I think that makes sense.
Right.
I guess I could just break here instead, but it's the same thing because I'm just gonna return res here anyway.
What about the case where you're you're done? Oh, I see. I see. Return res. Okay. 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 Does this work? Let's see.
I'm not sure actually. Let's see. No, apparently not. It's missing by one, so I might be forgetting to add one somewhere. Where am I missing the one? So this comes in as privileged. Oh, my bad. I'm stupid. I forgot to set res height. So here is, I gotta reset that. That's probably why. Oh, that doesn't fix it. What? Oh, wait. Oh,
Oh,
no.
what?
Wait, no, never mind. I did this. Wait, what is wrong with it? Yeah, I don't see the issue. I guess I can just print stuff and see what's wrong. Yeah, let's print the height and print height instead. And then I guess I'll print the heat too. See what's in there. Alright, so at height 2, previous height was 4, that's fine. The heap was empty, so that means we didn't use it yet. It's free. And 7 and 2, that means we have to use it. So at this, oh yeah, because this heap is printing before, I should probably print it later.
We also want bricks and ladder.
Oh yeah.
Oh, actually, you don't need ladders, but bricks.
Yeah, just bricks. Yeah, okay. I will print that. I guess over here. Okay. Let's take a look real quick. Take a look. See. Okay. So yes, that's 7.
Oh, I see. If length of heap is not greater than letters, then nothing happens. By the way.
Wait. If length of heap is not greater than letters. Oh, this.
Then
Oh wait.
yeah, this isn't always the case, right? So usually you skip the first guy.
Wait. What do you mean I skipped the first guy? So okay. So this means if length of heap is greater than letters, that means we need to use bricks. But then there's no other.
Oh, so length of heap wasn't greater than letters at the beginning, and you didn't res +1, so that's why you're off by one.
Wait, doesn't this? Oh, this else is for the diff. So I need another else for this one, which is just looking weird now because I have many res +1s everywhere. It just looks like a ladder of else's. Is there a cleaner way to do that? I mean, I think this will work.
I think there's a cleaner approach if you use the. Oh yeah, I mean that's fine, but um, yeah, if you use index instead of incrementing res, then
yeah, so
then you
yeah,
use
so
it-
without using
you
res,
use
we
it.
just return it instead, right?
Right,
Yeah.
exactly.
So it's cleaner. So just get rid of this, get rid of this, get rid of this. Yeah, we just return res and return the length of the height heap.
Right, and then you don't need creep height, you don't need height, you just use I -1 or something, right?
Yeah. Wait. do I still not need that then? No, I think we can still use preflight, but instead of using it, what are you doing? You're just looking at how do you compare with the previous index?
Well, I mean, if you're
Well, I'm starting
presumably
with
you're
first index. Okay, I see what you mean. So yeah, I can just if I do in range length, right? Is that what you're saying?
yeah.
And then instead of doing this one dash, I just do range of 1 comma that. And then I use heights, or this would be I. And then it would be heights I minus heights I minus 1. And then, yeah, then there's no more height here. Or pre-height. It's just the heap and bricks. And then, yeah, that should be fine. I don't need this anymore. And then, yeah, I just return, if it finishes here, that means it went through the whole thing, so you just return the length of the heap minus 1. And this is the exit condition. This is the only time you return.
Not heap minus 1, it's height minus 1.
Oh, yeah, you're right. Heaps is the wrong one. Yeah, you're right. Okay, length of heap minus, okay, that should be fine. Length of heap.
But also, if you don't have enough bricks, then you couldn't get to the next one. So you should return I minus 1, right?
So if, wait, this case is bricks is greater than. Oh, yeah, so this means you don't have enough bricks at this point, right? Why is it minus 1? Wait, no, this is res. This res is wrong. What is it? We're returning indexes now. Yeah. Is it I minus 1 or is it I? Cause we're I is the next index over. Yeah, so it is I minus 1.
Yeah.
Okay. Yes. Okay, that should be fine. Okay.
Oh, hang on.
What's up?
Oh, actually, no, that's fine. Let's see. Okay, yeah. Okay. I think that should work.
That should work, yeah. Oh, I didn't close the bracket.
Input's weird.
Yeah, I didn't close the array. Okay, yeah, that one. That one works. Oh, nice.
Oh, nice.
Yeah, this is a lot shorter, yeah. Okay, yeah, I didn't understand why I did that back then, but now it makes sense. Yeah, you basically the min is you're trying to use the least amount of, like, basically you want to save your ladders for the big stuff, basically. So you pop out the bricks and you just pay with bricks. That makes sense. Okay, yeah, cool.
Okay. Yeah, I need to bounce.
Yeah, no problem. Thanks.
Again, later.
Yep. See ya. Bye.